Welcome to our Angular 4 test-driven development with GitLab-ci continuous integration mini tutorial. Everything I show you, you will also find in the matching Medium tutorial I will link in the description. You will need a GitLab account, you will need an installation of Node.js, and I suggest you to use Visual Studio Code for editing. So let's start. I will go to my terminal, and if I never created an Angular project, I will install Angular CLI. And I highly recommend you to always use Angular CLI also for your production project. It's just amazing and gives you a great structure with all the patterns that they suggest from the Angular team. So let's install Angular CLI. The @Angular stands for the sub-repository of the Angular packages. And with this command we can install Angular CLI. And now if I want to create a project, I just run the command ng new, and the project we create will be called Let's Learn. And I always define a prefix, LSL in this case, so we can start the project. This will now set up all the folders and files and configurations needed for a nice Angular 4 project. It also runs npm install, which will install all dependencies needed by Angular, and there are many. It also sets up the test environment containing Karma as a runner that runs all your tests in a browser, and in addition it installs Jasmine as the actual JavaScript test framework. So you write your tests using Jasmine library and you run them using Karma. But to make things easy, you can use Angular CLI to do all of this. So let's go in our project. So when we open our project, we'll see that we already have a whole application in Angular, and we'll already have a first test file for our app component spec.ts. So the app component is our main component that is loaded, and if you didn't do any Angular development before, I suggest you to now watch a tutorial about basic Angular development. Okay, so as we want to do test-driven development, we want to first write our tests that match the features we require, and then we will fulfill this functionality so the tests succeed. For that I go into the terminal and run ng-test to see if the tests work. So I can actually run ng-test in my project folder, and I can keep it running, and whenever I save something, the tests will be rerun. So you see, now it started a debug version of Chrome to show us our current application and the app's tests that currently succeed, because it's the default tests from Angular CLI. So now let's break those tests. If we go in the spec file, we have our typical TypeScript imports at the top. We get the setup of the test environment, which is mainly consisting of the test bed. The test bed represents kind of a fake Angular module where we want to run our single component in, the component we actually want to test. And then Angular CLI also gives us some basic tests to check if the component is created, if there is a variable called title in the component which is set to LSL, and if this variable is shown in the h1 tag. So first of all we want to rename our application, so we will call it Let's Learn. So we'll change the test first because we do test-driven development. So now the tests will fail because the application shows LSL and we now expect it to show Let's Learn. But that's a bit boring, so let's write a new test. So what we want to do is we want to create a button that increases a value called points by 1 every time we click it. So let's define the test that tests this functionality. So it should increase points by 1 if button clicked. So this is actually the test function. And the test function also expects a callback function, which we will run asynchronously because we have a view and we want to make sure that everything is happening in the right order. So let's see. we have to get our fixture, we have to create our component, we have to make sure that the changes in the view are checked, and now we can get the HTML. First, we want to check if our component has a property points and if it's set to 1. So let's see, fixture, and then we have a component instance, and then we can check the variable points. And to check something, we use the function expect and add to be 1. So this is our first test. And of course it fails because the component doesn't have the property points yet. And now we want to click this button we don't have yet, but that's test-driven development. So let's do that. So we call fixture debug element, which represents our actual view. From there we want the native element. From there we can do query selector and we select the button. And in this case it's simple because we only have one button. And then we click the button. And that's actually clicking a button in a browser. In this case it will use Chrome. So now when I click this button, I want to know if my component instance has now the points variable set to be 2. So this test checks the points variable to be 1. It actually clicks a button in the view and then it checks if the points variable was increased. And as you may guess, the tests are failing. And now they're even throwing an error because the points property doesn't exist. So now let's develop this functionality. So we go into our app component TypeScript. We first change the title to Let's Learn, as we defined. And now we set the points variable to 1. And now I want to add a function I will call +1. And this will increase this points by 1. And I called it points, so I have to call it points here too. And then I go to my HTML, and now I get a nice big chunk of HTML, which I really want to remove because it doesn't make any sense. So let's add a title showing the title variable, and now let's check if this already works. So if we go back, we'll see, wow, it executed 4 tests and only 1 failed. So the first 3 tests already work. So to make the others work, we will have to add a button which calls the +1 function, and we'll call it +1, and just for convenience we'll show points value. And now if we go to the test environment, we see, wow, it worked. And this is test-driven development. So let's actually look at the application. I will stop my tests and I do now ng-serve O to open the application in my browser. And you'll see it just works. And this is the amazing thing about that. But tests make really fun if you have a bigger application, a lot of tests, so you can work continuously and you always know if you break something. And to make sure that this is always checked, we want to use something called continuous integration. So whenever we commit or push a change to our repository, we want to have the server actually integrate and test those changes so we know they work. For that we will need a different browser than Chrome, because on gitlab-ci on the server we want to run a headless browser, and for that we will use PhantomJS. So let's install the necessary libraries for PhantomJS. I will now be a little bit lazy, go to my tutorial and just install those libraries. So first of all, I install the pre-built PhantomJS library and the Karma PhantomJS launcher. And then I will also install a dependency for something it's called Intel, which is a JavaScript that provides browsers with a certain functionality that they may not support. So PhantomJS doesn't support as much features as Chrome, so we have to use a lot of JavaScript libraries that make PhantomJS support those features. So we'll install this also. And as this is installing, we'll go here into our application and we'll open something that's called polyfills. And polyfills are exactly those JavaScripts that extend your browser with the missing functionality. You'll find it in the source files polyfills.ts. So let's now import all those polyfills so the necessary features are available in our PhantomJS browser. You'll also have to do this if you want to run your application in an old browser. And now we have this Intel feature we want to import down here. So those are the polyfill. And now let's see if this is installed. So everything worked out. And now we go into our Karma configuration. You'll find on the root folder of your project. And within that Karma configuration, you will find something which is called Karma Chrome Launcher. And now we'll just add the Karma PhantomJS launcher. And if we scroll down, we'll find a list of browsers. So here we can add PhantomJS as an additional browser. And now we can run our tests with the PhantomJS browser. To do that, we'll run ng-test browser PhantomJS, and I'll tell it to watch false because I just want to run it once without waiting for file changes. So this will now run everything in kind of a browser emulation in PhantomJS. That's something we can also do in GitLab-ci. Okay, so now if we want to use GitLab-ci, we want to upload it to a GitLab project. For that, we'll just add a GitLab project. Let's call it Let's Learn CI, and then create the project. And now we can just copy the Git URL, and Angular CLI created the Git repository for us. So what we'll do now is we'll just add the remotes. Git remote add origin with the URL. And now this added the URL to our Git configuration. And now let's add our changes and let's commit them to our local Git repository. And now let's push it to the server and hope it works. And for that we'll need to set an upstream, so we use the option U and we tell it to push to origin, which is our GitLab remote, and what we want to push is the branch master. So that's fast. Okay, so now what we have is we have everything on our GitLab repository, so we just make sure it's up here. But GitLab isn't doing anything with it because this is just a basic repository. To have GitLab do something with it, we have to define a gitlab-ci configuration. And to configure that, I will write a so-called gitlab-ci script. And I will create that in the root of my project. So I will create a new file gitlabci.yml, and now I'll add the configuration, and just let's go through it quickly. At the very top you will find image node latest. This represents a so-called Docker image. Docker is kind of a container which gives you the possibility to run an application in a configuration that you define. So you can have your application run in any environment, and you can very precisely define and choose your environment. It's kind of a virtual machine, but it isn't. It's much faster as it's not a separate operating system. So for you, what you have to know now is you have to choose a Docker image, which will be node latest for this example. And this will run a Docker whenever you want to run a build, which will run whenever you commit the change. Then we can define a cache. We will cache node modules. So between every build, the GitLab-ci will provide the cached for the node modules from the previous build. This will increase the speed of the build because this way it doesn't have to download all the nodes packages every time. And now we have the actual script, which we'll call test let's learn, and then we have the script which will do an npm install. This will run inside the project folder that will be checked out on every push, and then we'll run the ng from our node modules. We'll run ng-test with a single run and the PhantomJS browser, and we don't want to watch it. So let's save that, and now let's commit this to our Git repository. So git add gitlabci.yml and then commit it and now push it. And as soon as this gitlab-ci is on the server in your repository, GitLab will start to build your application. So if we go here now, we have this button pipelines where everything about GitLab-ci is happening. I really love GitLab-ci. Of course, there is Travis CI and there is Jenkins. There are many other build systems, but for a team and a company, GitLab is really amazing to use for Git, for continuous integration and also continuous delivery, something I can show you in the next video. So just let's go to the running build. So I didn't do anything else. I just created the project. I set this GitLab-ci config and I pushed everything to the server, and magically GitLab-ci is already running a Docker, and it's going here to install all the packages needed for the project. With the second build it will be much faster as it will have all the packages cached. And now hopefully this will work. So let's see if our tests also succeed on the server. GitLab will, by the way, send you an email on every build that fails. And the minute of truth, it's starting the test with PhantomJS. Now it's building the application, and Karma will run the build application in PhantomJS, and our test succeeded. So this is it. Our continuous integration build worked. You just witnessed test-driven development with Angular 4 from scratch, putting it into a GitLab-ci project and running the build with every push. I really recommend you to do this for every project so everybody in your team can enjoy the power of continuous integration. Have fun and see you in the next video when I show you how to do continuous delivery to any cloud you wish to do.